Hello, everybody, and welcome to another episode of Connect Conversations. Today's conversation is all about design for reliability, and it's brought to you as a part of MOBIUS Connect YouTube ongoing series, Connect Conversation. I'm Kim Fugger, the manager of MOBIUS Connect, and I will be your moderator for today's session. First, I'd like to take a moment to introduce the hosts of Connect Conversations series, our global reliability improvement experts, Doug Plucknette and Ron Moore. Doug and Ron, are you both here with me?
We're here.
Okay, fantastic. Well, before I pass the microphone over to you guys, I want to encourage our audience here today to submit any questions that you may have into the panel, the question panel of your GoToWebinar screen. And Ron and Doug will be more than happy to answer your questions today live on the air, but no need to feel called out. They will answer all of your questions anonymously. Doug and Ron are here to provide their advice and perspectives from their experiences are here to help you. All right, Ron and Doug, I'm going to pass things over to you.
Okay,
Right.
Thanks. Doug, you want to go first? You want me to go first?
Yeah, sure, why not? When we came up with the idea of Connect Conversations, the first thing Ron and I did was make a list of things that we could talk about over the different times that we had set up. And I think we had a couple pages of those. And then, as we get close to these, then we sit down and say, okay, what are we going to make sure we talk about when we go over, for example, this week, design for reliability. And that was another one where you look at the topic and go, holy smokes, there's a lot in here, right? So we had another full page of things just to talk about today. So we do have a lot to cover. And this is certainly a topic that is of interest to many, many companies around the globe.
Yep. All right, I'll kick in there, but I wanted to give folks maybe a little of my personal background. My first 20 years of my career were spent in projects. So I was a project engineer at designing nuclear subs, and then I was a project manager, and then I was director of projects, and then I was VP of projects. And so I've got a pretty good background there. The interesting thing to me, or the relevant point to me relative to my background, is reliability was never an issue. It was budget, schedule, meeting the specs and standards, and doing for example, factory acceptance test or the acceptance test. And reliability, life cycle costs weren't really a part of the consideration there. Now, they were kind of implicitly, because from time to time, you'd have comments, well, that doesn't work very well, we need to do this, or that machine, that vendor is not very reliable, they don't provide good pumps or whatever, we need to use these others. So, but reliability and life cycle cost as a concept, as a principle, as a policy, just didn't exist, So now we had the usual stuff, budget, schedule, specs, standards, Gantt charts, PERT charts, critical path method, we had all that, but none of the other. So I think it's really important that we stress this concept of designing for reliability, because that's where reliability begins. If you screw it up in the design, you can't recover it in the way you operate and maintain, or at least not much of it.
And that's the point I was just going to make. So you spent your first 20 years doing that. I spent the better part of my first 20 fixing those mistakes they made in design.
Well, you're welcome. I kept you busy. So, yeah, well, what can I say? I mean, there was no expectation around that. So, if your bud's held accountable for budget and schedule, you don't care much about anything else, Yeah.
So, and as a result of those budget constraints as well, the other thing that happened was, okay, find the most cost-effective supplier, not the best one, not the most reliable one. And as a result, we got stock rooms full of different brands of pumps and motors and valves and actuators, right? Because we really didn't think about reliability up front.
Right, I know. By the way, for the folks out there, I'm doing a half-day I think it's half day. Maybe it's 5 or 6 hours. Anyways, I'm doing a workshop on this very topic at IMC this year down in Florida for terrestrial handling. So if folks are interested in that, they might want to participate in that. So anyways, let's maybe get into some of the issues here. Like I said earlier, reliability begins in the design. So if you don't take that into account as a part of your overall policy, strategy, implementation, whatever it may be, then you're not going to be as successful. And my experience has been that most folks don't do that. They're constrained by capital budgets because my experience, and Doug, you may have participated in some of this, you put together an estimated cost for something, right? A project. And you go through, you got work breakdown structure, you got all the usual stuff. And you go about, you put it all together and you hand it in. And what's the first question that comes back? Doug, you probably know the answer to this.
Where can you cut some money?
Yeah. Now, can you do it faster? Where can you cut the budget, the estimate? And you go, okay, I can probably do it here, and you go make these optimistic estimates, and guess what happens? Well, you usually blow through them. In fact, there's some data, I think McKinsey did the original study, but Chris Harrington with ARMS, I think, reported on it. And big major projects, typically on average, and the variation is quite high, on average they run 80% over budget and 20% past the original schedule. So they'll be a year or two late and almost double their original budget. So you wonder what's the point in doing this when there's a high probability that's going to happen. What's your opinion there, Doug?
It really comes down to the companies that I've worked with that have done this well, basically set, just like you would do for a root cause analysis, right? They set rules or standards to say, okay, if the project is so much money, then we need to start talking about reliability and design, right? One customer, for example, was any project over $250,000, they had to do design review for reliability, RCM analysis so that they had a maintenance plan for when they started up, and then discussion, they were held to making selections on suppliers, pumps, motors, valves, things like that I talked about, so that they weren't making additions to their stock room. So those are the things that companies need to really start doing. Of course, reliability block diagrams starting out. What are you looking for? What level of reliability do you need from this project right from the get-go? If you don't talk about it, then the likelihood of you achieving it somewhere down the line are slim and none.
Yeah. Well, one of the things I harp on is reliability is not just the equipment. Certainly equipment is included, but I'll say this again. Reliability is the ability of a production system, that's mostly what I deal with, to deliver maximum quality product on time, in full, at the lowest sustainable cost. So it involves more than just the equipment. So the point being, for example, if you got 10 or 50 or 100 different products, then changeovers need to be expeditious. That gives you more access to the capital and more products that you can make. So, and if you don't use the right material, I've just, for example, off the top of my head, I was in a food plant once where they processed pineapple, and all the equipment around the pineapple processing area was carbon steel. Now, I don't know if some of you may not be aware, pineapple is really acidic. It just chews up carbon steel, bang, like that. So some of the decisions are just quite foolish because it just reflecting on my experience, and we're going to get into how you manage some of this and what the business case is here in just a minute. But there's an incredible pressure to do it for less and do it faster, just to get it approved, right? Because the board and the big dogs are always worried about capital spend, particularly the accountants and cash flow. So there's always pressure to minimize that. But there's not much consideration being given in most of the companies I've dealt with. Sounds like you've had maybe a better experience in one or two. Not much consideration given to, downstream.
Oh, the vast majority are still doing nothing about this. So when you talk about the system, I mean, we're actually talking about who operates it, and do they have a level of training to be able to operate it correctly, right? From when we went from push button type things to man-machine interface, there was a step change there necessary in training, right? So you want your people to be able to do that. You have to be able to maintain that piece of equipment, right? That's part of reliability as well. So what considerations were put forth in the design phase for those types of things, operating and maintaining, right?
Yeah.
Not just what footprint it'll sit in. Any group of fools can do that. They can fit that 10 pounds of stuff in the 5-pound bags. I've seen it over and over again. But then when it comes time to operate it, maintain it, even supply it, take things in and out in terms of your product, right?
Yeah.
If all those things aren't considered, safety on top of that, right?
Yeah.
Environment. The list goes on and on.
Yeah, no. Well, the point being, I think, or one of the points you're probably getting to is that when you have a major capital project, the operations and the maintenance folks who are familiar with that kind of equipment, with the process, need to be involved in the project.
Absolutely.
Period. And there needs to be budget for them to be involved and time for them to be involved in the project. Otherwise, you're not going to address those issues. I mean, I don't know about you, Doug, but I've been in situations where, you buy a skid-mounted pumping station, right? And guess where the pump is? Buried behind the pipes. And you go, well, how the hell am I supposed to get to that? Or you have a heat exchanger. Guess how you have to pull the tube bundle? Through a wall. Or you have a hydraulic pump located on the top floor of an area, and you have to cut a hole in the roof and bring a crane in to lift the damn thing out. I mean, it's just stuff that's obvious to you if you're a maintenance guy or an operator. You locate. The thing that really annoys me is you have these things, locate valves and pipe hangers to suit. To suit what? to suit who? I mean, to suit, what the hell does that mean? And then you have piping and valves and pumps that aren't labeled, aren't color coded, aren't, it's hard to identify what the hell it is they do and how they do it. So unless you have somebody there to guide you on what that means and how to do it, you're going to wind up with a mess.
So it reminds me of a story of a brewing company that I worked with, and I'm walking from one conference room to another with a vice president of that company, right? And we go by a project that they're probably 80% through with it. The tanks are in, the pipes are in, the pumps are in, the wiring's done, right? And they're finishing up on this thing. And as I walk by, I stop for a minute, and he says, "What are you looking at?" And I said, "You didn't have anybody from maintenance involved in this project, did you?" And he says, I couldn't tell you. It's not at the level that I work with. He said, "Why? What's the problem?" I said, "Well, number one, you mixed metals on that pipe. You got 316 stainless and 304. That's never really a good idea." I said, "On top of that, the whole thing should have been turned 90 degrees. You can't get at the pumps the way they are. You got to step over all the pipes to get at those. If you turned it 90 degrees, put the tanks against the wall, put the pipes out here. Now you can come in from the aisle and get those pumps out. The way you got it now, you're going to have to, which is probably not part of the project, you're going to have to put a beam in above there with a trolley so that you can hook a come along or a chain fall up to get the motors and pumps out, right?"
Yeah.
And he shook his head and he says, "I think we're going to have a lot of work for you."
Well, you know, I see bimetallic flanges all the time.
Yeah.
All the time. It's just, and you look at that and you know, it's just, well, it's just marvelous. Because particularly if it's a bimetallic, you know, carbon steel against something else, anything else, you know, you're going to get that cathodic action. One thing I would suggest to folks out there is hopefully you have some sort of OEE measurement, overall equipment effectiveness or asset utilization, where you break down the various losses into their component, schedule, unscheduled, rate, quality, changeover, all that sort of thing. Use that data in the design to try to address some of the issues around managing those losses better in this project. Because if you got to get the operations and maintenance guys involved, number one. Number two, use the data you've got on your losses to try to, design those out. Either make it easier to do the changeover, use, stainless steel instead of carbon steel for pineapple plants, that sort of thing. So I think it's really good data. The second point I'd make about this OEE measure is this: if you're a site manager and I'm the boss, I'm your boss, I'm VP or president or whatever, you come to me and you say, well, boss, I need $10 million or whatever to expand capacity on this line. And I say, well, what's your OEE on that line now? And you say, well, it's 60%. I say, okay, well, what's a world-class number or a really good number? And you say 80%. Well, it's a career limiting moment for you, because you've just asked me for $10 million when you've got 20% more capacity in there. Go get that first before I give you any more money. Now, if you need $500,000 or $1 million to get that other 20%, I'm happy to do that, but I'm not giving you a bunch of money to go build equipment that you run like you're running what we've got. I just wouldn't do it. So anyways, that's my thought there. The other thing that we need to do is make sure that the design folks, specific to incorporating the operations and maintenance folks, we need to make sure that they've got a good close communication with the purchasing guys, and that the purchasing guys are cued in on the fact that you're using a life cycle approach or a total cost of ownership approach. And you want common equipment after you select it. You don't want to have, you don't want to do mix and match on all the components, because that's going to drive up maintenance requirements, maintenance training, spare parts, and errors, because you got far more complexity when you don't have some sort of commonality amongst the equipment. So you have
which by the way, with the skid mount stuff that you talked about, that's one of the biggest issues, right? You get what that company thinks ought to be, they've already made agreements with suppliers for what valves and actuators and sensors they're going to use, right? So you can get stuck with those. And that was one of the things that I worked with another customer on to say, okay, what are you doing to yourself? Are you adding to the problem, or is it something that you just haven't taken the time to go back to them and say, can we have Apollo ball valves as opposed to Worcester, right? And he said, no, we haven't done that. I said, sometimes it pays to just go back and you tell them, we'll pay the extra $5 or $6 a valve because that's what we stock in our plant. We don't need to have those other ones. Or worse yet, some valve that's made in another country that you're going to be stuck if you don't stock it with a really long lead time, right? And those are the things you need to look at when you're in this design phases, especially when you're working with those purchasing people. Oh, for goodness sakes, don't give us anything with a lead time of more than a week, right? That's ridiculous.
Yeah.
So.
Well, and the other thing too that can happen, speaking of skid mounted stuff, is you'll provide the supplier with a functional spec, right? It has to operate in this environment, has to deliver this kind of flow or this kind of heat transfer, give them a functional spec. Well, and you're right. I mean, they're going to use the cheapest thing that they can get a hold of, so they come in low bid, so they get the job. And that may or may not be what you really want if you get your operators and your maintainers involved. So it really needs, you know, a more thoughtful approach to it, you know. The other thing that we need to make sure of, you know, spare parts. You know, when the project is turned over, the spares need to be in the warehouse, and
Yes.
the PM plan needs to be loaded into the CMMS, and the maintenance requirements and all that. And a lot of folks don't do that. That costs more, but it costs you a whole lot more if you don't do it then.
Exactly. And I have a list of this that I give to my customers when they're talking about capital projects. Here's what should be part of every capital project in terms of maintaining that asset. Number one, the detailed equipment hierarchy down to the component level, right? So that should be all set up in whatever your CMMS you're using, whether it's SAP, Maximo, I don't care. You then do criticality ranking. So where does this asset rank with the other assets at your site? Right. So when the work orders start coming in, what gets the highest priority? We need to make sure that's been done. The full bill of materials, and that's where most companies start to fall down with this, right? As you said, they got to have it set up in the stock room, but what size is it? What material is it? Is it threaded? Is it flanged? Who is the vendor for it? Where can we get it? What's the lead time? All right. And then if that stuff isn't suitable, then should we have it in our own stock room? So that full bill of materials, whether you stock it or not, should be linked to that hierarchy. All right. Yep. Then the equipment maintenance plan. So when it hits the ground running, we've got a plan of what are the PMs we're going to do, what type of condition monitoring should we be doing? Is it full time? Is it stuff that needs to be on routes? And then lastly, standard operating procedures for the operators. How are we going to operate this thing? Right? How are we going to start it up? How are we going to shut it down? What's entailed in doing a product change? Right? All those things should be ready to go before you even start accreditation.
Yeah.
So.
Yeah, I think you covered everything. I've got a little checklist here myself. So, in the design, you should complete the asset registry criticality analysis. I think you mentioned that. Spare parts, PM, PDM, condition monitoring requirements, and the maintenance plans for each equipment, OEM manuals, bills of material, capital routine spares in the warehouse, maintenance program loaded in the CMMS. And by the way, according to some folks out there, and Doug, you may have a better idea on this, you need to add 2, 3, 4, 5% to your capital project budget to make sure you do all that.
Yes, absolutely. That's all should be part of capital. And that's one of the things I tell the maintenance, managers and supervisors, man, you're getting hosed when you don't get that stuff done as part of a capital project because you end up having to pay for it out of your budget, right? And have you budgeted for people to have time to do that? Well, no, right? Well, then how is it going to get done, right? And the truth is, it doesn't get done.
Well, it gets done haphazardly because you're trying to fix stuff while you're trying to put together, the PM plans and find the manuals and find the bill of material and all that sort of thing. So that ought to be a milestone for the project. You can't turn it over until you get all this done, So I just, Now, another comment, installation startup, and as you would know, the highest risk of inducing defects and failures is during the installation, startup, and commissioning phase of not just a project, but any equipment. That's where you're most likely to screw it up.
You see it all the time after big turnarounds.
Yeah, right. When you're going to have it back online? Well, we're starting tomorrow. And then a week later, you finally get it online because you got all the screw ups that you had to deal with for a week, because you didn't have good standards, good procedures, good processes for addressing that risk of defects and failures at startup. And notionally, you're about 10 times greater risk of doing that during startup than you are during normal operation. because that's when things don't go well. But that also means what? That the operators and the maintainers who are going to take this thing over need to be what? They need to be participating in that effort as well, so they can guide you on what needs to be done. Another thing to think about, according to the data, and Doug, you probably have more data on this than I do. I'm just looking at all the RCM studies, but something on the order of 80 to 90% of equipment out there fails randomly.
Yes.
Now, if it fails randomly, what does that mean as a practical matter? Well, it means doing time-based replacement is probably not a good idea unless you have specific data that articulates how long something's going to last based on specific operating and maintenance conditions. And you can have a wear-related component, but if that baby is subjected to different operating parameters, characteristics, and different maintenance practices, it will fail randomly.
Yep.
I'll guarantee it, because you induce more variation, more defects, and so on. So you got to have a really good condition monitoring, in particular a commissioning program when you start up to validate the quality of the installation and to allow for maintenance guys to determine when defects are developing, so you can take appropriate action to minimize the consequence of that pending failure.
So and then understanding those devices, because I'm going through this currently with a customer right now that we're looking at a bunch of control valves and control loops. So the valve, the transmitter, and then going back through your software, right? How it's controlled, right? And they say, well, we're always coming up with no scheduled maintenance on these things. I said, well, your valve can wear, right? But you have to know what that wear is. Is it, how long does it take? And if you don't know it, is there a way that you can monitor it to say, based on flow, based on pressure, we're seeing that the valve is starting to wear. Outside of that, we have some of those that are regulated. What can we do about that? There's not too much you can do about control loops that are regulated by the government to say, okay, you need to test those every so often, because they'll say, well, you just told us time-based maintenance doesn't work on those. And yeah. I said, well, now we're getting into something that's totally different. We're talking about safety, right? Or we're talking about the environment. And what they're saying is they want to make sure the device works properly at a moment in time, right? And that's all it's telling you is today it worked properly. It tells me nothing about tomorrow. And with those random failure patterns, it's just as likely to fail tomorrow as it is next week or last week, right? The probability is the same.
Well, the point there, though, is that we're telling you not to do time-based intrusive maintenance. Time-based, and we do want you to do inspections and monitoring and calibrations and lube changes and filter change. We want you to do all that. Those are generally on a time basis, either runtime or calendar time. And so those are all good things, but replacing stuff just because a year has passed is probably dumb. Unless, for example, if you got a slurry pump impeller and you operate that sucker, 24 hours a day, 7 days a week, and it's the same slurry, then you're going to have a pretty good idea that you need to replace that impeller after 6 months. That's okay. And, you can probably, wear plates in certain, mining operations, brushes on a DC motor, it's wear or corrosion, erosion related, for which you have data and consistency of practice, then it's okay to do time-based. But that just doesn't apply very often. At least that's my experience. So let's see, what else do I want to talk about?
Well, another mistake I've seen, Ron, from companies is they will often do their process hazard analysis or their process safety analysis as part of the design review, but too early, all right? and they'll say, well, how can it be too early? Well, there's an argument here of when you should do those things, but if the equipment hasn't been installed, do you know where your head knockers are? Do you know where the trip places are? Do you know the places that you need to build a step over, right? Sometimes I'll see those things where they get done early, and when we sit down and do them at the point where either you've got good drawings that show elevations or immediately after installation of major components. So you might still be wiring up, you might still be doing control loops and things like that. That's the time to do those things. Whether it's RCM or process hazard analysis or process safety analysis, sit down and go through the system and say, what are some of the things that maybe we missed in this design that need to be looked at or addressed before we get ready to start up here?
Yeah. Well, the other thing to be aware of, I think, too, is, and I worked with a company and they had a big major capital project, and they did what they called a FMECA, failure modes, effects, and criticality analysis. And it showed that, well, this system or this equipment has this risk and this one has less and so on. It was a little Pareto chart. Well, guess what? When they actually started operating the plant, that thing wasn't worth a flip. Because what happened is, as they're operating the plant, they said, well, this system over here is really critical. We got to make sure we look after that one. Well, it showed up way out on the tail end of the Pareto in terms of actual consequence to the production process. But the one that they didn't pay attention to, it was way up high on, in the queue of actual, failures and consequences. So you kind of have to be a little bit careful with your criticality analysis, because if that drives you to pay attention to one or two things to the exclusion of all the others, you're probably going to screw up, because those others will come back to bite you straight away. So there has to be a policy, a philosophy, a strategy around, well, look, I'm going to give this one a little more attention, but I can't ignore that one, because that's going to leave me in a bind with a lot of problems. So another thing that I forgot to mention earlier was the vendor PMs. Vendors are going to come to you and you're going to buy all this stuff, and they're going to recommend certain parts and PMs for the equipment. I'd be really circumspect about that, because vendors have a bias, right? What do they want to do?
They want to sell you parts.
They want to sell you more stuff, because they went low bid to get their equipment in there, and now they got to make it up on the parts. And so they have a bias to sell you more stuff. So that's one problem. The second problem is that they may not understand your operating context. So if you got one operating mode that's under this environment and it's intermittent, that has a very different set of failure modes than another operating context where it's running continuously and in a high stress or hostile environment. And you got the same set of PMs under both circumstances. So it's really important that you take into account their bias to sell you more, and whether or not they understand how you're going to operate this stuff.
Right. So sometimes it can get even worse than that. They will tie their warranty to you doing those things, right? Yep. So you need to make sure you're looking at that very closely up front. I worked with a customer, this is, had to be more than 10 or 15 years ago, that we were doing an RCM analysis on a centrifuge, and the manufacturer of that centrifuge had their warranty tied to them replacing this high-speed bearing. And I can't remember whether it was a year or 18 months, but it was relatively quick, and it was an expensive bearing. It was $18,000 or $20,000 bearing, plus the downtime to do all that. And their company actually was the one that would come in and do it, right? So it just so happens they're doing this while we're doing the RCM analysis. And I said to them, look, I don't know what you're going to do about this particular one, but the next one down the road, don't sign on to that warranty, right? Let's go out and take a look at this guy, you know, what he's doing, and, you know, how is it changed? Is it something your own people can do? So we go out there, he's already got the old one off of there, off the shaft, and he's got the new one, and he's got a piece of 2x4, right? And a lead hammer, and he's going tink,
Oh,
tink,
geez.
tink, 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 tink. I said, you know, the guy's putting defects in your bearing when he's putting it on there. And their reliability manager was just like, what in the world? So I said to the guy, what are you doing? You can't do that. You're putting defects. He says, no. He says, that's why. He says, I used a 2x4 and a lead hammer. He says, they're soft. And I said to him, can I have both of those and look at them? So he hands it to me, and I stuck them up to his forehead. And I said, now, if I hit that, tell me whether or not that's soft.
Well, yep.
And he says, you think that really, I said, yeah, you're forcing the race against the balls. You're just, you know, damaging the crap out of that bearing by hitting it like that. You're putting flat spots in it, right?
Yep.
So
yeah, on that same topic, you know, I was working with a company in Australia, and they were to maintain their warranty, kind of like what you just mentioned. They were obligated, I think it was every 3 months, they had to take this piece of equipment down and replace certain components within the equipment. Well, the downtime plus the cost of that, you know, replacement exceeded the value of the equipment over the course of a year. You know, so the warranty, in my mind, wasn't worth a flip. You know, why would you spend as much as the equipment's worth over the course of a year if that's just to maintain the warranty? You're giving up all that production, you're spending all that money, and the sum total value of that is equal to, over 1 year, is equal to the value of the equipment. So that warranty isn't worth a flip when you look at all the total costs associated with maintaining it. So I said, to hell with that warranty, it's not worth anything. And not only that, but I don't know if you've ever been involved in trying to make a warranty claim, but the first thing that happens is, and I'm not saying ignore the warranty at all, but recognize the first thing that's going to happen is they're going to say, well, what'd you do to break it?
right.
And then you get into this contest, you know, where everybody gets wet and smelly and nobody's happy at the end. And so I'd just be very, like I said, circumspect about doing stuff to maintain the warranty. In some cases, it's probably worth it, but in other cases, it may not be worth it. And besides that, you better keep good records of what you have done to sustain the warranty. Otherwise, they're going to come back. If you can't prove it, then you didn't do it, and therefore the warranty is void.
So we've talked about the maintenance and operations folks being involved in these capital projects. At what level do you see that, right? Because that's one of the common questions I get from customers. When you say that the maintenance guy should be involved, how much? I said, well, you know, I'm not talking your whole work center. I'm talking 1 or 2 people, a mechanical guy, and an instrument electric guy, right? Right through the whole project, from design and an operator, so 3 people, right from the design phase all the way through to accreditation, right?
Yep.
Their time should be 100% dedicated to that, and they'll go 100%, right? I said, trust me, you're going to get the value out of those people.
Yeah.
By
not only that, but from time to time, you'll call in external resources, experts who know better about a particular component or piece of equipment. And so you're going to want those guys in there from time to time. So, and that's probably the equivalent of another person. Yep. And if it's a giant project, you know, for a big plant, hell, it might be a dozen people. So, but if you skimp on that, you'll regret it later. Because go ahead.
The things I've seen, they're endless, right? One just recently, they're got 200, several different rates of steam at their site. 470, 250, 40 pound. Well, they've been having all kinds of issues with backing up of their condensate, of their 40 pound condensate.
Yeah.
So what do they end up finding, you think? Well, they had a project a couple of years ago, and when it got tied in, they tied the traps from the 250 pound steam or the 500 pound steam into the 40 pound condensate, right?
Yeah. How's
I
that
wonder
supposed to
why.
work?
Yeah, I wonder why now your 40 pound steam system isn't working very well, and the condensate's backing up in it, right? So
Yeah.
those types of things you look at and you go, that's why you have those people involved, because they sometimes the lines aren't labeled as much as we'd like to see them, right? And people make mistakes.
Yeah.
So they will find those things.
Yep. Now, a couple other points I'd like to make on projects, and that's this. I've worked with a large U.S. company with global operations, and I worked with the VP of engineering, and he had data on their capital projects. Of course he did, because he's in charge of them. And we went back and looked at those capital projects, and as it turned out, it would take them about a new major capital project, it would take them about 6 months to get up to 70% of the anticipated production rate. And then it'd take them another year to get to 100%. So think about that. It takes you a year and a half to get to 100%. Well, the question that I posed to him was, well, what's that worth to you? What would it be worth to you if you could get that up to where it's supposed to be in 6 months instead of a year? Well, that's 3 months of lost production. So what's 3 months of lost production worth to you? Well, that's a number. Now you're going to make some assumptions here that if you apply all these principles that we've been talking about, you'll achieve that, getting it online in 6 months. And the other question, got some more data from a different company, but similar hostile industrial process. It turned out a year after a major capital project, they would spend 6% of the capital cost on maintenance. Then the next year they'd spend 5%. Then the next year they'd spend 4%. So my question was, and you said, well, what's going on here? Why are you spending all that extra money in that first couple of 3 years? Well, they were fixing all the screw ups from not installing it right, not having the right parts, the lack of access, and a litany of things. I said, well, what if we could address that up front? What would that be worth? So I went through just a mock analysis, taking that data, 3 months extra production plus reduced maintenance costs based on those numbers. It turns out you could spend an extra 10% on that project, assuming you did all these things right, and you get that money back in the first year of operation, because you get all that extra production and you don't get all those extra costs. And so, now that's a nominal figure. Folks would have to look at their data and see what they've done and whether or not they believe they can achieve this and eliminate those losses if they apply these principles. I believe they can. And in fact, I've got a case study, a big, huge chemical operation over in England, where they were adding another production plant. They had, let's call it NICO 1 was operating, and they built NICO 2. Well, NICO 2 was a disaster. It took them an extra year and a half to get it online. They spent a truckload of money making things right and so on. So now they're going to build NICO 3. That, by the way, it's not its real name. I just pulled that out of the air. And I said, well, guys, why don't we take what we've learned and some of these principles and see if we can do it better next time? And to their credit, they did. In fact, the project manager for NICO 2, which was a disaster, was actually the project manager for NICO 3. And, you wonder why he didn't get fired, given all the troubles, but he didn't, but he learned. I mean, he's a veteran now. He knows where all the goblins and the screw ups are, and they got that plant operating within 3 months of startup instead of a year and a half.
Yeah.
By doing these things. And not only was it 3 months, but that plant has consistently outperformed the other plant where they had all the problems to begin with. If you get it wrong from the get-go, you're going to be fixing it forever.
Yeah, you're going to live with it, especially once the capital money is dried up. When they say, "Oh, we're through accreditation, and so we'll cover X more dollars for things that may need changes down the road." Once that money's gone, it's gone, and you live with it for the remainder. So long as that thing continues to run, that's your baby. It's your problem. Put it in the maintenance budget every year now, right?
Right. Well, and the other thing, I mentioned earlier, just based on the data I've got, you add 10% to do the things we've been talking about. And the other thing that happened was they didn't spend that money.
Right.
Because they found that because they got it right in the first place, they didn't have to spend a whole truckload of money on rework and redo and redesign and everything. And so they actually came in under budget, got it up to, full capacity in 3 months. And it's outperformed the previous plant, consistently, after that. So it just demonstrates that, that this stuff works. Now, I don't have, I've only got that one, example, but I do have Ramesh Gelati. I think a lot of folks out there know Ramesh. He had data from the Arnold Engineering Development Center on their major capital projects where they applied these same principles. And it turned out, you spend a little more money up front, but you get it back straight away. And I've got his data as well. So it just illustrates that this stuff works. We've got data, and if you can go back to Rita Mae Brown's statement, if you always do what you've always done, you always get what you always got. So if you're not happy with what you've been getting out of your capital projects, maybe you ought to think about doing something differently and applying these principles. So
I've had.
All right.
I wish many, many more successes with customers would do an RCM up front for just that reason. There seems to be a roadblock there. It's companies, they don't want to spend that money to do that type stuff up front, but it does work. We've seen those similar results. One customer had a system that they'd put in several other plants. Their typical startup was 3 months, and their punch list was pages long. The next one, we did an RCM analysis on it. They started up in less than 3 days, and their punch list was 4 items. So it does work. If there's one more thing that I'd like to cover before we sign off today, and that's standard designs. That lots of companies, I'm surprised when I look at rotating equipment that gets installed, pumps, agitators, blowers, things like that, and I'll ask them, what in the world? I just walked by 4 of them in the last 10 minutes, and there's no 2 that are identical in the way they installed them. And they look at me and go, what? Why don't you have a standard design for that, right? How much mass do you need in that foundation? How much straight run of pipe do you need in the suction and the discharge? Where should the first supports be on your piping, right? How far away should your first valve or restriction be, right? All those things make a big difference. Where are you bringing the conduit in from? Right down to electric rooms, right? I've seen some of them that were, you wonder, holy smokes, how the heck do they keep things running in here? I saw one place that had starters right out on their boiler floor, right? And I'm going, I bet you have a lot of problems with your starters, don't you? Oh, yeah, we do, right? Oh, that's amazing, right? They don't run very well, in dirty, dusty environments. It really should be clean and environmentally controlled. Right. Yeah. So those types of standard designs make a big difference. They're worth the investment to say, all right, if you don't know what to do, then go out and look at the 20 or so that you've got at your site, go back to your maintenance history and say, which ones perform the best. That might be a good place to start with your design, right?
Yeah. Yep.
Then go back to the manufacturer, even ask them. Sometimes they'll be very helpful in saying, this is the preferred method of installing. This is what you should do, right?
Yep. But another thing you might do, and you should have this, if you don't, is what I call quality build plans. And in fact, you could use those as a basis for a framework for a specification when you go out to buy stuff. And a quality build plan is just a document that gives you details on how you repair something, how you restore it. And it gives you dimensions, it gives you clearances, it gives you specifications, it gives you hole points, it gives you material, it gives you all that. And it's called a quality build plan. And that would be something I think would be quite useful to the project guys for, you know, creating standards and specs when they go out and procure equipment, you know. So, all right.
Ronnie, we've used our time.
Yeah.
Looking at it, we got a couple minutes left if you have something else. And I haven't seen any questions pop up there. I just looked about 10
nobody
minutes
cares
ago.
or nobody's listening. So maybe somebody will care and come back and listen to what we've said after it gets posted, you know. So anyways, there's, you know, we didn't get a whole lot into the details of where some of the numbers came from, or, you know, some of the principles on how all this stuff integrates and works together. But, you know, maybe it's as a tip or two in there, a nugget or two for the folks that are listening or that will listen. So I'll just leave it at that. I sat here for a minute. I could probably think of something else, but I won't.
All right. Well, once again, it's been my pleasure.
Yeah, thanks, guys. Whoever's out there, thank you for joining us, or whoever listens later, thank you for listening, and good luck to you.
Well, thank you guys for another great conversation. On behalf of the entire team here at MOBIUS Connect, we thank our wonderful audience for joining us today. Just a quick reminder, you can see any past episodes of Connect Conversations on YouTube, and we will share the link to subscribe to our YouTube channel in an email following this webinar. Be on the lookout. Most of our episodes typically air every other Tuesday at 2 p.m. And if you're interested in engaging with other industry professionals or would like to participate on the industry's live feed and forums on MOBIUS Connect, you can visit www.mobiusconnect.com to create your free profile. And be sure to follow us on social media at MOBIUS Connect to stay up to date with the latest community happenings. Thanks again for joining us. Have a great day, stay safe, and we will see you next time.